Hello again, last one. Number 5, the loudness of sound D, measured in decibels, dB, is given by the formula, there it is, where I is the intensity measured in watts per square centimeter, and T, the negative 16, is the approximate intensity of the least sound audible to the human ear. So pretty much A, B, C, and D, they're just asking us to use the equation that's given, plug in some different numbers, and solve. Some are going to be straightforward, where we can kind of just plug into a calculator and get a solution, and others are going to be a little bit more where we have to use our definition of log and solve that way. So for A, it says the loudness of 10 to the negative 13 watts per square centimeter. They want us to find the loudness when that's a whisper in decibels. So 10 to the negative 13 is our I here, so this is I. So I'm going to plug that in for I in the equation. So for A, you're just going to have D equals 10 times the log of 10 to the negative 13 over 10 to the negative 16. So simplifying here, this equals 10 times the log. Remember our division properties? So we have a quotient rule of exponents. We subtract our exponents. So this becomes 10 to the negative 13 minus negative 16. Minus a negative is really adding, so this becomes 10 to the third power. So this is 10 times the log of 10 to the third power. And we can put this in the calculator, or you can also recall that when you don't see the base for the log, it's base 10, and these two 10s cancel each other out, and we end up with just a 3. So we actually end up with 3 times 10, and we get 30 decibels as our answer for A. Otherwise, you can just plug that into a calculator, and since it is base 10, that's something that your calculator or your phone can do, or even the calculator possibly on your computer, or one you can find online. So D equals 30 decibels for A. Okay, I'm going to erase this. And again, you guys know the deal. You can go back at any time, pause, whatever you need to do. For B, find the loudness of a normal conversation at 3.16 times 10 to the negative 16 watts per centimeter squared. So again, we're given this. This is our I. So I'll plug that into the formula. D equals 10 times the log of 3.16 times 10 to the negative, I believe that's 10th, yes? I know it's a little blurry, over 10 to the negative 16th. So again, simplifying here, I can simplify this guy here with this guy here, and I would have 10 to the negative 10 minus negative 16. Again, minus a negative is adding, so this becomes 10 to the 6th power. So D equals 10 times log of 3.16 times 10 to the 6th power. Completing this, again using a calculator, D equals 64.997, so I would say it's about 65 decibels, the loudness of a normal conversation. So that's for B. Okay. For C, they now want us to find the intensity of the sound that's experienced by an orchestra member seated in the front of the brass section if the sound is 107 decibels. So now they're telling us what D is. And this is where it gets just a little bit more tricky. So I know D is 107, and this equals 10 times the log of I over 10 to the negative 16. So solving our equation here, we would start out by dividing both sides by 10. So now I have 10.7 equals log of I over 10 to the negative 16th. So I'm going to have to change this and use the definition of logarithm and change it from a log into exponential form. So remember, this is a base 10. And now I'll go in and I'll label all my parts, right? So log, the base is always b. Whatever it's the log of is always a. So this whole thing is going to be a, and it's always equal to x. So now when I put this in my b, I'm going to write it up here, b to the x power equals a, I will have 10 to the 10.7 power equals I divided by 10 to the negative 16th. I can calculate 10 to the 10.7 power and figure out what that is, but that's going to give me a rather large number, so I'm just going to leave it in exponential form right now. And how would I solve the other side for y? Well, I have division, and to undo division, I simply multiply. So I multiply both sides, so times 10 to the negative 16th, and this side times 10 to the negative 16th. So this will cancel, and I'll be left with I equals 10 to the 10.7 times 10 to the negative 16th. And we can plug that into our calculators, or we have multiplication with the same base, so we could add our exponents, and adding 10.7 plus negative 16, we get negative 5.3. So I can do 10 to the negative 5.3 power. I'm just going to move over a slide here. So we had I equals 10 to the 10.7 times 10 to the negative 16. Adding those two together give me 10 to the negative 5.3 power, and that's using our product property of exponents. Then actually calculating that with the calculator, we get that I is equal to about 5.01 watts per centimeter squared. All right, that's the end of 5C. I just was running out of room on that last page. Okay, 5D is similar. It's asking us to compare two sound intensities. So one that's 47 decibels and one that's 42 decibels. So let me go back here so we can look at the actual question. So for D, it says, how many times more intensity does a sound of 47 decibels have than a sound of 42? So in this case, we'll have to find the intensity for both sets of decibels, 47 and 42, and then we can compare the two numbers. So I'm going to start this on a new screen because otherwise I think it's going to just be all jumbled and messy. So let me get to a clean screen here. And I'll start with the 47 decibels. So 47 equals 10 times the log of I over 10 to the negative 16. And I'm just going to go through and solve this the same way we did the last one. Divide both sides by 10, giving me 4.7 equals log of I divided by 10 to the negative 16th. And again, remember, this is base 10. Using my definition of log, this is my b, this is my a, and this is my x. So writing it in exponential form, I get 10 to the 4.7 power equals I divided by 10 to the negative 16. Because I have division here, I can simplify this by multiplying by 10 to the negative 16th on both sides. So I get 10 to the 4.7 power times 10 to the negative 16th equals I. Adding 4.7 and negative 16, because we have the same base, gives me 10 to the negative 11.3 power. And I can actually leave my answer like this because if you notice back throughout the question, I'm just going to flip back real quick, all of the intensities are all left as 10 to an exponent of something. Even in the original problem, 10 to the negative 16th. So I'm actually just going to leave this solution that way. It makes my life a little bit easier too. So 10 to the negative I'm trying to make this decimal a little bit better, 11.3 power. I am going to label it watts per centimeters squared is equal to I. So that's for 47. We also have to figure it out for 42. So we have same idea, but 42 equals 10 log I divided by 10 to the negative 16th. Same steps, divide by 10, so 4.2 equals a log of I divided by 10 to the negative 16. Rewrite, I have base 10, rewrite as 10 to the 4.2 equals I divided by 10 to the negative 16th. And then multiply both sides by 10 to the negative 16. So I have 10, 4.2 times 10 to the negative 16th equals I. Adding these two guys together gives me 10 to the negative 11.8 power. And that, oops, I want to label watts per centimeter squared equals I. So here is for 42 decibels. So all that work, and I still have one last thing to do, because the question was how many more times intensity is the 47, so how much bigger is this one as compared to the 42. So to compare those two, all I have to do is divide. So for the last one, you take your 47 decibels, whatever your intensity was for that, and divide it by your intensity for your 42 decibels to find out how much bigger or how much more intense that one is. So our intensity for the 47 decibels was 10 to the negative 11.3. This is 10 to the negative 11.3 power divided by, our other one was 10 to the negative 11.8. And when we do that division, here we get 3.16. So the 47 decibels is about, I'll just write about 3.16 times more intense than the 42. Okay, so that's the last part of that problem. You have to be careful and go back and actually read the question. So that part, you found both the 47 and 42 and did all that work, but in order to get the question right, you have to answer what it's actually asking. So there's how you do that one. All right, I hope I've been helpful. Remember to do your take-home quiz and hand it in the day it's due so that you not only get credit for homework, but you get your summative assessment grade as well. See you then.